Okay, let us now proceed to multiplication of polynomials with 3 or more terms. Okay, so we will still be using the same principle, the distributive property of real numbers. So the only difference is there are more terms. So let's have one example here. So we have 3y minus 2 multiplied by y squared plus 5y minus 1. Okay, so we are multiplying a binomial with a trinomial. Okay. Okay, so what we do first, we distribute the y. Okay, so y is y squared, we get 3y squared. And then we have here 5y plus 15y squared. Oh, sorry, so this is cube. And then 3y multiplied by negative 1, we have negative 3y. Okay, so if let's distribute negative 2 this time. So negative 2y, that would be minus 2y squared. And then here, that would be negative 10y. And then negative 2 times negative 1, that would give us positive 2, right? So let us now add the like terms if we have some. So okay, so we have 3y cubed, so there are no other cubes. We have here 15y, we have here 15y squared, and we have 2y squared. So 15y squared minus 2y squared, so that would be 13y squared, right? Then negative 3y minus 10y, so that would be negative 13y. Okay, and then plus 2. Okay, so this is our answer. And let's have another example. Okay, have here y squared minus 2y plus 2 by y squared plus 2y plus 2. Okay, so have here y squared by y squared, we have y to the fourth, right? And then y squared multiplied by 2y, that would be plus 2y cubed. And then here plus 2y squared. And then this one, we do this one. Okay, so that would give us minus 2y cubed, and then minus 4y squared, right? And then minus 4y. And then for the last one, we have here this is blue, this one. Okay. And then we have plus 2y squared, then plus 4y, and then plus 4. Okay, so let's combine like terms now. So there are no other y to the fourth. Okay, so that's only one. And then cube, 2y cubed, and then minus 2y cubed, so these cancel out. Okay, then squared, how about squared? 2y squared. So we have another 2y squared here, so this will be, we have 2y squared here and 2y squared here. That's 4y squared. And then we have a 4y minus 4y squared here. So that will cancel out as well. Then we have another 4y here, negative 4y, and then we have a plus 4y. Okay, so we are left with this very simple answer, y to the 4 plus 4. Okay, so that's basically it for multiplication of polynomials with 2 or more terms. Okay, so now let's move on to special products of binomials. Okay, this is a little bit more interesting. special product of binomials. Okay, so what do we have? We have here, the first one is sum and difference of same terms. Okay, sum and difference of same terms. So what we have here? Okay, so this basically states that a plus b times a minus b is equal to a squared minus b squared. Okay, so if you use this to solve more efficiently. So if you see something, two binomials that are structured this way, you can immediately write the answer, a squared minus b squared. You don't have, you no longer, although you can perform it, although you can continue with the distribution if you like, but since we already know that this will be the output if ever the structure of the binomials is a plus b and a minus b, then you can just simply write out the answer right away. So let's give an example here. Let's say we have x plus 2 here and x minus 2. Okay, so if we perform this, we have x squared minus 2x, and then we have here plus 2x, and then minus 4, right? So this will just cancel out if this is the structure. So we are left with x squared minus 4. So the same thing here. So let's give another example. Let's say we have 2x plus 3 and then 2x minus 3. So our a here is 2x and our b here is 3, right? So they're the same structure with this form. They have the same structure here. So let's just write immediately 2x squared minus 3 squared. Okay, so that would be 4x squared minus 9, right? Okay. So these are just efficient ways of solving, because these are known already, that this, you know already that this will be the result, so you can just write the answer right away. Okay, so let's have the second one. Have the square of a binomial. Square of a binomial. Okay, so let's start with an example first. Say we have x plus 2 squared. Okay, so this will be x plus 2 multiplied by x plus 2, right? Okay, so if we evaluate this, we have x squared and then plus 2x and then plus 2x again and then plus 4, right? Okay, so we have 2x plus 4x plus 4. Okay, so for square of the binomial, you can directly go to this form without performing all of this again, because we already know that will be the answer. I mean, it follows this pattern. Okay, so we have here a, for square of a binomial, we have these patterns. Okay, a plus b squared is equal to a squared plus 2ab plus b squared, and then we have a minus b squared is equal to a squared minus 2ab plus b squared. Okay, so these are, so let's say for example, for in our example, x plus 2 squared has the form this form, right? It has this form, and as you can see, the answer is of this form, right? So x squared. So our x here is, our a here is the x, right? So we have it the a squared or x squared, and then plus 4x. 2 times ab. 2 times ab. So the a here is x, then the b is 2, right? So it is equal to 4x. Okay? And then plus 4, which is the b squared. Okay, let's use these patterns for other examples. Let's say we were given x minus 5 squared. Okay, so following this pattern, we can write directly x squared minus 2 times x, and then this is 5, right? 5, and then plus 5 squared. Okay, so the answer will be x squared minus 10x plus 25. Okay, so that's it for square of a binomial. And then for last one, we have here cube of a binomial. Okay, cube of a binomial. Okay, so we have cube of a binomial. The patterns for that will be a plus b cube and a minus b cube. So this is basically equal to a plus b multiplied by a plus b squared, right? Then this is a minus b multiplied by a minus b squared. And we know from the square of a binomial that this is also equal to a plus b multiplied by a squared plus 2ab plus b squared. And this will be equal to a minus b times a squared minus 2ab plus b squared. Okay, so let's have an example. Let's say we were given x plus 4 cubed. Say we're given that. So the equivalent expression for that would be x plus 4, and then multiplied by x squared using the square of a binomial, x squared plus 2x times 4, right? And then plus 4 squared. Okay, so this will be x plus 4 multiplied by x squared plus plus 8x plus 16. Okay, so we can then distribute this x plus 4. So x cubed plus here 8x squared, and then plus 16x, and plus 4x squared plus 32x plus 16 times 4, that's 64. Okay, then what do you have here? Have here x cubed, and then 8x squared plus 4x squared, that will be 12x squared, and then 16x plus 32, that would be 48, right? Then be 48x, and then plus 64. Okay, this will be then our final answer. Okay, so just remember that you can always perform the distribution, but it is convenient if you already know these forms, so that example, if you're answering a quiz or an exam, you can answer it very fast, because just have to memorize this form, and then you can write the answer directly, so no need to distribute. Okay, so that's all for this. Thank you.